The next lowest scored question I have looking on here is number 25. So let's go over to 25. So number 25 says Carla is designing a box using the diagram shown. Reach length is in inches. There's the diagram. And then it says if Carla wants the maximum height possible to allow for a box to have a volume of approximately 20 inches cubed, what height should Carla make the box? All right, what are your ideas on this problem? I hear volume formula. What is the volume formula? This is not on the formula chart. Length times width times height. Okay, as I walk the room on that practice exam, some of the students that were about to get it wrong, so the data is a little skewed. That I helped a lot of students on this one. Here's where a lot of students, what they did correctly is they saw a volume of the 20, and where did they put that in? The V. That a lot of students did correctly. What I saw frequently is on the length, they put 11 minus 2h times 5 minus 2h times h. If you know what's wrong with this, tell me. What did I do wrong here? You need parentheses. It's groups being multiplied. You need a parenthesis around length, around width, and around height. As I plug this in the calculator, though, I'm not going to use the letter h. I'm going to substitute. I'm going to say that h is going to become x. So the height will be represented by the x. So what I'm going to do here is erase that, put x's. And I want you, if you have time, to do as quickly as you can, to graph this with me. So there's my equation. I'm going to go to Desmos and graph these. We have 20. That was the volume. It's supposed to equal the length, 11 minus 2x. And I'm looking over here. If you're wondering, how do I remember this? I'm just looking at the dimensions. And that's going to multiply times the width, which is 5 minus 2x. And that'll multiply times the height, which we're saying x. Again, on this version of Desmos Star, through Clever, nothing happens. And let me go home here. On your version in School City that I had up, it was supposed to be Star, it showed it. So it might show your values. But either way, what I'm going to do now is I'm going to insolve by saying y equals the left side, y equals 20. That's the volume right there that we're looking for. That's the target volume, 20. And now let's put in the volume formula. Y equals the volume. All right. Now I have a pretty good idea why this problem was only selected correctly 38% of the time. You can see it was only 38% correct. I was about to tell a lie there, so let me just stop myself. Okay, so here it is 38%, but I was about to make a statement that most people chose the wrong answer, which is not true. They were evenly divided. Here's what I want to point out. On real world, this is a real world problem. Where do your answers have to be? They have to be positives. Okay, let me walk this through with you. The red represents the volume. Do you know why? Just think about it for a second. Why would this graph ever go negative if it was volume? Don't answer on the real world. Answer in theory. Why would a graph go negative if it was a length times a width times a height? What would make it go negative, the volume? If it was length times width times height, what would have to happen to make the value become negative? One of those sides has to become negative. Okay, so here's the idea. As height gets bigger, what's going to happen to your length and width? As the height, the h gets to be bigger and bigger numbers, what's happening to your length and your width? They're getting smaller. Why? Because you're subtracting 2 times the h. Do you follow? There is a point in time where this volume goes negative. It's at the point 2.5. Let's think about why that is. If your height is 2.5, what is 2 times 2.5? 5. What is 5 minus 5? This point right there means you have a width of 0. Is that possible to have a width of 0? No. This becomes negative because the width is now negative. The only reason it ever comes back positive is because this length also becomes negative. And what's a negative times a negative? A positive, but it's not real world. So all this part of the graph should be rejected over here. So I'll put a restriction on here that x cannot be greater than 2.5. It can't actually even get to be 2.5. So you would ignore all that over there. So now when I look at my answer choices, there's only 2 to choose from. There's no longer 3 to choose from. There's two. We want the maximum height possible. Remember, height we represented with an x. Which x is larger, 0.5 or 1.7? 1.7. So the maximum height would be c. This would be the minimum height. That's the minimum height. This is the maximum height. This value we rejected, just to be clear, we rejected because that was the, without the restriction, let me show you that one again. That 5.77 is this answer over here. But we rejected this one because the length and width would be negative. Length and width would be negative. If you plug those in, you would see that those side lengths would be negative. And that's not possible.
So you would have to put a restriction?
You don't have to. You just have to know that on real world problems, as soon as the graph leaves the first quadrant, it's no longer realistic. And so you would just ignore that part of the graph. Finally, there's one more answer. It's this value. What would this actually represent right here in the problem? Now, don't tell me in theory. Don't just say it's the max. Tell me practically for this problem. What does that represent right there?
So that's
So what's the red graph represent again?
so that's the volume.
That's the volume. So this would be the
The volume for
maximum volume. Did we want a maximum volume?
we want the last one.
We wanted the maximum height. That was the x. That's the max x. The volume was supposed to be 20. It wasn't supposed to be its maximum volume. It was just supposed to be 20 in the volume. Does that make sense on how these answers came about? So this right here is the height at the maximum volume. Height at max volume. And that's not what we wanted. So there's a little rundown of the different answer choices to kind of explain that problem. Because if you understand it, then if you get another one similar, you'll know which one to collect. Okay, did I walk through that thoroughly enough for you, or do you want me to pause and go again?
We did it.
You got it now? I beat that horse to whatever the saying is. Better just stop there. All right.